All right. So great to see this many people showing up to the talk. I'm Ståle Pettersen, and I'm heading the product and application security team within Schibsted. We are 3 people in total, so quite a small team, getting a 4th member in 1 week. And this talk is about our journey the last 3 years, trying to improve the security in the products within Schibsted. So the agenda for today is a short introduction, some background and context, some guiding principles that we came up with, and then the actual implementation and rollout, and then some sort of learnings at the end. So I'm Ståle Pettersen. I've worked within security and/or development the last 15 years. I've also been part of the OWASP Oslo chapter for 6 years, together with many other chapter leaders. And I've had this position since August 2019, when the team was created. But I've been in Schibsted for 6 years. So Schibsted, to give you some context, is a collection of different brands within the Nordic countries. And we have very diverse companies, like we have newspapers, we have marketplaces, like Finn in Norway. We also have food delivery services, we have wine guides, we have podcasting platforms. So it's sort of very diversified. And every company is responsible for their own security. So this is quite key. It's not like we centrally in Schibsted are responsible for the security in Finn. Finn is responsible for their own security. And what we try to do is to make their job easier. So we try to provide them with great security services and also support. So that's how we look at ourselves. We are simplified, a support team, which doesn't sound as cool as cybersecurity experts or something like that. But that's basically how we look at ourselves. We are the support team. So some tech numbers around Schibsted. So we are about, 1,000 developers, spread about 150 team-ish. We have about 10,000 Git repositories. We don't have a standard programming language. We use everything, basically. We have around 500 cloud accounts, mainly in AWS and GCP, but also in the cloud we use everything, I would say. We have about over 100 Kubernetes clusters running. And as of today, we have 55,585 domains and subdomains. So this is sort of the context we are operating in here. So 3 years ago, what we had as sort of big security solutions within Schibsted was only one thing, and that's this Vulkan security scanner. It's actually open source. And this is a system where we have our teams, and then we have the team members in the teams, and then the teams themselves can update the inventory manually. So this is our assets, this is the team, this is the team members. Quite good solution, but it's sort of all manual, and it's not that comprehensive, I would say, or wasn't at that point. So that was basically the starting point back in 2019. And also what happened in 2019 is that we got a new CEO in Schibsted, Kristin Skogen Lund, and she sort of brought security on the agenda and hired a new CISO in Schibsted that was in top management, like it was very high up in the hierarchy, which is very important. And it was decided to sort of level up the security in Schibsted by running a cybersecurity program. So we decided to base this on the NIST cybersecurity framework, which have sort of 5 main categories or areas to focus on, and they have 4 levels. And it was decided that we should be at level 3 as a minimum baseline. So it's not, we should not stop at 3, but everyone should be at level 3 at the end of the program. So this was back in 2019, and it all started in January 2020. So this is sort of the full cybersecurity program, and what we're going to talk about today is the application stream here. But this is just to show you that a lot of other things was happening at the same time, but we will focus on the application stream. And sort of simplified, it can be summarized as inventory, secure by default, application security, cloud security, threat modeling, and training. That's sort of what we have done. So this is what we will be digging into today. So the first thing we started on was to develop an internal solution that we called application inventory. And it's basically a system that automatically collects the applications and domain information from many different systems within Schibsted in an automated way, which gave us an understanding of the external attack surface in Schibsted. So this sort of gave us what do we actually have that we need to protect. So that was the starting point. So we developed this, and today it has sort of matured to more and more things. But here you see an example. You would search for a domain like schibsted.com, and you would see that, okay, this domain is scanned by Detect by DeepScan and Asset Monitoring and Vulkan. And you also know about this domain from Route 53 records, on DMARC, which is an email security solution, and Ports Group, which is sort of a registrar for domains that we use. So we sort of have integrations into these different types of system. Another example would be we'll search for Schibsted.tech. Okay, we see we also have some information about this. And then we search for Schibsted.cc, and I said, okay, we don't know anything about this. So if we see this, this is probably a phishing domain. Because before we started, we wouldn't know that, like, Schibsted.tech, is this a phishing domain, or do we actually own it? That sort of information we didn't have. So it's surprisingly useful to know what you own. So over time, this has sort of this application inventory has developed to something more. So for example, today we automatically scan or we try to discover new subdomains every hour. We sort of try to look for new subdomains. So the number of domains that we own, it changed from hour to hour, basically. We also now sort of pull in information from all the security scanners that we have, so we know what's covered and what's not covered by the different security tools, and also who owns the different domains, so we can actually reach out to the teams behind them if there is a security issue or something like that in the domains. And we are working on sort of the next step, which is sort of giving it a full path and then getting the sort of Git repository to the application running on that path. We have it for some thousands of applications, but it's not sort of well implemented right now. So working on it. And then also another thing is that this solution is available to everyone in Schibsted. So they can do the same lookups as long as they are connected to the VPN and SSO solution. We also have like a private API for us, so we can pull in vulnerability information from the different security solutions, sort of a thing that we need internally in the team. So this was sort of the first thing that we did. I would say sort of a easy decision to discover your own attack surface as a first step. But the next thing, what should we do? That's a bit harder to decide on. So we came up with some guiding principles. Where the first one was basically there is no technical silver bullet for product security. And the teams really need to be aware of the risk and then get empowered to improve security through training and tools. So we're really creating this security culture across Schibsted. Another principle was that usability is more important than security. And what we mean by that is that developer experience and usability is more important than the security capabilities in the tools. Because if it's really painful to use, nobody will use the tools. So it doesn't really matter if a great tool finds like one very, very critical vulnerability, but it's hidden in 10,000 false positives, then nobody will actually find that thing. It's a bit of a fire torch to say it, but we really believe in it. And also that ideally we don't want developers to go to this place for security and everything else is sort of in GitHub, for example. We want security to be part of the daily workflow for developers. So security is not something on the side, it's part of sort of your daily workflow. And we also want to focus on practical improvements. So not overloading teams with unrealistic requirements and low priority alerts. We really want them to sort of alert about the important stuff that they actually need to do something about. And we try to be non-intrusive, so sort of not break builds every day. Of course, as we're not sure, maybe we can do it at some stage, but not in the beginning at least. Another principle is to sort of do the easy things first and not start with something very hard or intrusive. So it should be easy to operate and non-intrusive. And then as you mature, you can sort of go into this a bit harder to operate and intrusive, like Vulkan, the scanner. You can just enter a domain and it will just scan. You don't need to do anything or change how you build your application or anything like that. It's very easy to onboard and operate. We also, so different companies call this different things, like you have a golden path or a paved road or a common platform. And we call it the golden path. But we really want to create a secure platform or a secure golden path that has security built in and that's secure by default. So not every team has to sort of improve security, it's sort of provided for them. So that will be ideal. Another advantage, if you can focus on a golden path, is you reduce the redundant work, you focus on this one platform, and also it helps when you negotiate contracts, because then you sort of have bigger scale and not have 10 different contracts on smaller scale. And in general, we believe we can sort of have better quality if everyone focuses on one thing. So this was the guiding principles that we came up with around how to secure products and sort of securing the software development lifecycle, which can also be visualized like this in different phases, which is more a classical representation. So where should we really start? So what we did next actually was to have the different phases of the life cycle, as you can see horizontally here. And then we mapped out the different tools and capabilities and services that we already had within Schibsted, not related to security, but just what platforms and tools do we have and where do they fit into the SDLC. So you have like Grafana and Spinnaker, we have GitHub as a source repository, like try to map out everything. Because we really want security as well to be in all the lifecycle phases. So we then mapped out the perfect world, like if we can just say, we could pick and choose and get everything we wanted. We basically wrote down our dream scenario. And then you start to see that it's quite a lot of things that you want as a security person. Another thing that we sort of did to try to help us make a decision was to try to predict which of these central services would have a high adoption in 2 to 3 years. Because if we focus on something with high adoption today, but in 3 years everyone will have offboarded, then it would sort of be a failed project. So we made some sort of predictions, and I would say they are quite accurate. So the GitHub repository and the application platform called Skates, which is a Kubernetes setup, they had like 3% adoption at this time, but we expected it to be sort of growing over the years. So we said, okay, let's try to harden this application platform. So we decided that was our next step. So we call this Kubernetes setup in Schibsted, Schibsted Kubernetes, or just Skate for short. And it's based on the AWS EKS setup. So we have, or it's a team in Schibsted, this is not a security team that operates this, but it's the developer foundations team. So they have a Kubernetes setup with batteries included, meaning it's a very easy way to get the Kubernetes platform up and running, and you have metrics and logging and automatic upgrades of Kubernetes automatically provided for you. And the deployment model is that the developer foundations team get access by the team that wants a cluster. They sort of give this is AWS, so they just get the permissions to deploy a Kubernetes cluster into their account. So it's not like we have one AWS account with 100 clusters. It's like every cluster is deployed into the team's own account. And that also means that they have the freedom to sort of tweak and do what they want, the team themselves, even though it's sort of a standardized Kubernetes setup. And it's over 100 Skates clusters that's deployed and running today. And this also makes it sort of, so this is the shared responsibility model for all cloud providers, I would say, the top one. So what this makes it sort of, the team need to care, like, of course they need to care about security, but it takes some part of the security away from the team. And this central developer foundations team and security team together can sort of take ownership of more of the stack, so the developers can focus more on development and product development. So on the more technical things that we did was to switch out the host OS to AWS BottleRocket, which is a container optimized OS, and it has quite good trade-offs between security and compatibility. And it's very focused on avoiding persistence and backdoors that comes with that. It comes with some pretty good SE Linux rules by default. And they have removed sort of a lot of binaries, and the binaries that's there are hardened. And it's also very easy to sort of do upgrades of the OS and the host system. It's not a perfect sort of security thing because it's not a virtual machine. It's sort of the closest thing you get to without going all the way to virtual machines. So it's sort of and everything, it will not break anything switching to this. So it's sort of a okay trade-off, I would say. Another thing we did was improve the audit capabilities in the Kubernetes clusters. So we enabled guard duty for AKS, which gives us threat intelligence, like alerts when unusual things happens, and also good auditing logs, we also decided to deploy like an audit role into each cluster. So we, in the central team, sort of get visibility if we need it into the clusters in case of Log4Shell, for example. It's a good case. We also, and by that audit access, we could also run things like Kubescape, which is sort of a security compliance checker tool that's open source. Another thing that we did, because in AWS EKS, it's quite open by default when you deploy a cluster. So what we did was deploy Cilium to sort of restrict network access and remove the permissions that was there by default. So you can spoof network traffic and things like that, and also limit network traffic to within namespaces in Kubernetes. This was not free for all like it used to be. And on the ingress side, so incoming traffic, we by default have a IP allow listing. So when you spin up a Kubernetes cluster, it's default locked down. It's sort of not public to the world by default. And it's also very easy to enable web application firewall and DDoS protection that AWS provides. So this was mostly hardening and open source tools used as part of that. But we had a cybersecurity program, so we actually had some budget, so that was good. So we needed to invest in some solutions. And the first one that we focused on was dynamic application security testing. And the reason is that we could just, this is a scanner running in the cloud. You just give it a list of domains and it scans it for web security issues and you get results back. So the team doesn't need to do anything, just provide a domain name and that's it. And in this, we evaluated these 5 vendors. And how we did it was we had a custom application that we had deployed, and we also used the OWASP Juice Shop as a sort of benchmark for the tools. And in addition, we sort of have like, do they have a good API, good documentation, good recommendations in their findings? And also, is it easy to use, of course? It's important. So we decided to buy Detectify because they have a very simplified UI and there's not a lot of configuration options, which can be good and can be bad. I would say it's good in this case. And very low false positive rates, which is very important to us. And some quite interesting findings, even sort of outside of the typical web security space, like if they found a S3 bucket as part of a website, they would go and look on the permissions to that bucket, for example. And they have a very interesting crowdsourcing model where third-party hackers, researchers can say, I know about this vulnerability, or this is a way you can check for Log4Shell, or there's a Jira vulnerability, this is how you can check for it. And so they sort of contribute the checks to Detectify, and they get paid every time Detectify finds one of those in any customer. The researcher gets paid per finding, which is a quite interesting twist, I would say. One of the first things we also did was enable AWS Guard Duty in all of our accounts. And this looks at all network traffic, all CloudTrail events, meaning all the changes that's done in the account are analyzed. It also looks at the DNS logs and sort of try to detect insecure changes and signs of breach. So if there is a DNS request for a known command and control server, they would trigger an alert. And this has actually detected crypto miners, for example. It will also detect if a credential issued to one EC2 server, if that's used from another server or from not AWS, but from a private machine, it will alert and detect that. So we had, for example, one case where we had credentials issued to a server in Stockholm being used from Vietnam, which was a bit unusual. And I think the sort of return on investment for this service is really good. And it, like the cloud providers have a lot of security capabilities that you can buy. And it's not always a good bang for the buck, but this specifically, I think is really good investment to make. So we also needed to look at the source code. Most of our companies develop their own products, so we have a lot of source code. So a SAST is basically to identify insecure code before it's deployed to production. So it operates on the actual source code. And in this area, we looked at SNCC code, Contra security, and GitHub security. And what we decided on was GitHub Advanced Security. And the main reason is that they are able to be part of the workflow in GitHub. And it's a bit annoying that other tools can't do this. Like if you choose SNCC code, for example, like they can break a build, but they are not allowed to sort of show everything in line in the pull request. That's sort of a platform feature that's part of GitHub Advanced Security. And this is sort of gold, so I understand that GitHub requires money for this, but it's a bit annoying as well. Because then we must have this, and then maybe can buy another solution on top of this. But yeah, so it was not that difficult to say, okay, we need GitHub Advanced Security. But this also makes it possible for open source tools to be embedded like this into pull requests, which is really good. And yeah, so if you click this show path, it will actually show you all the classes where the data originates from and sort of flows through all your classes and into the vulnerable function. And in this dismiss dialog, you can sort of say this is a false positive, this is part of a unit test code, so it's not important, and sort of dismiss it inline in the pull request. And also, we can write our own tests in this language called CodeQL, which is really powerful and complicated, so not straightforward. But we have the capability and we have gotten training from GitHub. So hopefully this year we will be really good at CodeQL. GitHub Advanced Security also comes with some other capabilities, like we have dependencies through Defendable, which doesn't support all package managers. So we also have a guide internally on how to use RenovateBot to have automatic updates of dependencies. And the GitHub Advanced Security also comes with secret scanning included. And you can also write your own regex to detect other types of secrets. Now onto the cloud. And in cloud, so the cloud is very complex. There's a lot of things you can do, but we decided that we want a cloud security posture management solution because cloud misconfigurations is the most common root cause for data breaches in the cloud. And we sort of want to prevent those from happening. We looked at CloudGuard, Prisma, and Wiz. And when you start looking at vendors in this area, they do a lot of things. They have container security, data analysis. There's so many capabilities they have. So we said we will only look at cloud misconfiguration, the CSPM part, and make a decision based on that, like who is the best at that. And then we'll take sort of the extra capabilities as a bonus to sort of narrow down and make it possible to make a decision. So we decided to buy Wiz. And Wiz is very easy to deploy. You basically just give Wiz access to your cloud account, like IAM role is basically what to deploy, and that's it. There is no binary to install or anything like that. They will just listen to all the changes in your accounts and find security issues, basically. They have a really good web interface, very easy to use and understand. Even though the cloud can be very complex, they sort of managed to make it simple and understandable. And they also have this CLI tool, so you can actually scan your infrastructure as code with the Wiz CLI to identify security issues before it actually deployed into the cloud, which of course is the perfect world. Everyone would do that, but you will always have security issues that you only see in the cloud. Like if you deploy a container image that doesn't have any vulnerabilities at this time when it's sort of created, but later when it's been running in production for 2 months, then there's a new CVE in SSH, for example. So you always need in production, but of course you want to stop a lot before it comes to production as well. So this is like the one example from Wiz, and to me this is sort of the holy grail. They really understand cloud, and I think this is a good example. So you have like a vulnerability on a server with external exposure, meaning it's available on the internet somehow, and it has high privileges. So it sort of knows that this VM here is exposed through this network interface, through this VPC subnet, through this gateway and load balancers and things like that. It knows, okay, it's actually exposed. And then you can see, okay, this specific server has a container or an application with log4j that's not patched for this log4shell vulnerability. And this server also have this specific AWS access key, and this access key has these permissions. So all of this is sort of understood. And I think it's quite, if you try to sort of draw this down, it's quite complex. But they managed to sort of make it easy to understand. And I think that's really good UX and really powerful. For the ones that sort of want a dark theme, yes, they have support for dark theme as well. Now, so towards the end of the program, we wanted to launch a private bug bounty program. And we evaluated HackerOne and Integrity as the 2 options. And the reason was that we already had Finn was running a bug bounty program on HackerOne. So he sort of had quite a lot of experience with them. But we also heard a lot of new Norwegian, or not many, but a few Norwegian companies that had launched programs on Integrity and was quite happy with that at quite reduced costs. So we ended up deciding, okay, let's go with Integrity because of cost, and also they have more and more Norwegian researchers, meaning if we need sort of bank ID login at some point for some solutions, we actually have those researchers available. So today we currently have 5 private programs. The 5th one launched today. And we don't, even though it's private programs, we talk about them in public, like today. So it's not a secret. So if you are a researcher and want to be invited, feel free to reach out and I will add you to the programs. So the 2 first programs launched in September, and until today, this is the statistics on the findings. So you have 4 critical findings that's been found, which I think is surprisingly good, but you never know what's actually there. Is it because there's so few researchers, or so you shouldn't feel too confident in these numbers, I would say. We also try to write up sort of a summary of the coolest findings, I would say, and share it internally. Like this one is a dependency confusion issue that was found in the program, which is quite ironic because the researcher that found this issue linked to a blog post explaining it all, and that blog post was written by us. And we also had open sourced a tool to scan for these issues. But since we were quite busy with this program, we actually hadn't set it up to continuously run an alert on it. So when we only ran it sort of ad hoc every second month or something. But this report got us to set it up properly. So in general, I think it's really good to run private bug bounty programs. Highly recommended. But some things you can't really buy yourself out of. And one of those things is security culture. So what we did was to create this training package for product teams. And it was an initiative to empower product teams to better understand, mitigate, and escalate risks in their products. And for this, we got help from an external consultants. We ran a pilot with 9 teams at the end of 2021. And then all of last year, we did the training with every team. That's about 1,000 developers with a quite good satisfaction score with 7.1 out of 10. But it's sort of hard to measure, I would say, in general, but not a total failure, at least, is what I will take that as. This training package had these sessions. First one was like, what is this package? What are we going to do over the next 3 weeks? We had a presentation to what risk is and how to handle risk, how to identify risk, how to escalate risk. A lot of risk talk in that presentation. And then we did a look at the team, like what's your current tools and processes around security and risk handling? Do you have a risk register? Do you not have it? Have you done threat modeling? Do you know how to do threat modeling? And then we had a session on teaching them how to do threat modeling and then doing an actual threat modeling with the team's system. And then the output of that threat modeling session was written down in a conference page and sort of making a roadmap for the team. And we also had part of the package, a presentation about all the security tools and services that we provide centrally in Schibsted. So they knew about what we actually had. So I'll show you some examples in more details, but this is sort of the toolkit that we had around risk that we created as part of the training package. The first one is what we call a harm assessment. It's basically an impact assessment. So we wanted the teams to be aware of sort of how critical is this product or this service for Schibsted as a whole. and sort of rank it, and then teach them to do threat modeling and identify threats, write down the threats in Confluence, and come up with controls or mitigations to reduce the risk. And if you identified risks that the team themselves couldn't really mitigate or remove, we would require them to add it to a risk log to sort of write down, we don't have resources, the competence to fix it, or priority could also be one. And then have a process on top of this risk log on how to do risk acceptance or how to mitigate these risks that sort of trickled up through these risk logs. So this is one example of a harm assessment framework where you have these impact categories. It's severe, major, moderate, and minor. And then you have sort of different categories around different aspects. You have brand reputation or financial loss or regulatory requirements it could be as well. And whatever you sort of, if any answers entered into this severe, then your system was severe. That's sort of how the logic was. And it was modeled behind the scenes, I would say. But this is quite complex, so we actually simplified this and created a Google form with logic in it. So you would sort of traverse this decision tree behind the scenes, but was very to the point for the product owners, sort of having explanation what a financial record is, and then do you have it in your system? Yes, no. And then at the end, you would get the score for your product. So this actually only take like a few minutes to fill out, and then you have sort of classified your system, and that comes with some security requirements depending on what level you're at. So we created threat modeling template in Miro, which is available to everyone in Schibsted because we want them to do threat modeling. So this makes it a bit simpler to get started. And we also train them in how to do threat modeling with this template. And it's nothing magical. It's regular threat modeling, I would say. So this is one example from the application inventory and the different systems that we integrate with. And then we have this Confluence template, which is sort of the output of the threat modeling session, where you write down the threats and mitigations, and then sort of what's the current risk, have we fixed it, and what's the JIRA tickets, and then if we have mitigated it, what's the sort of inherent risk afterwards. And for some reason, if you couldn't implement mitigations within a reasonable time, they would need to add it to a risk log. And then, based on your impact category, the harm assessment, we had this flow of who can take risk decisions. Because if you have a system that 30 Schibsted companies depends on, you can't really take high-risk decision yourself. It sort of needs to escalate up. So this is sort of the decision tree. So the colors are based on the harm categories. Next, maybe not a favorite topic for developers, but we really couldn't avoid it. We introduced security policies. No. But we think that the policies need to be very short and to the point. There is no point in having a 50, 100-page security policy document if nobody reads it, and it's impossible to actually follow it. Like there's no security services provided that you can actually use to fulfill the policy. So not even the security policy that wrote it could actually manage to follow it. So we said we'll create policies, but they need to be very short, and we will not create a policy until we have a great solution in place that actually follows the policy. So that means when we started, we didn't have any policies, and we sort of added it as we got the capability. We added a corresponding policy. So for example, SAST policy, this is the full policy. It basically says if you are severe, major, or moderate in the harm assessment, you need to do SAST code scanning. And then the team is responsible themselves for the findings. And then based on the harm category, this severe, if your system is severe, then you only have 2 days to review the findings. It doesn't say fix the findings. It says you need to look at it and evaluate it. And then if you are a major, then you have more time and etc. So this is basically the approach that we took to policies. So the cybersecurity program, did we reach our initial goal? So we set out to reach level 3. And at the end of 2022, we would say that we actually managed to achieve it, except in 3 teams, which is not that bad, I think. But of course, we have some learnings that I try to summarize here. So one thing that was quite painful several times actually was that when we negotiated contracts, we only negotiated contracts for the total licenses that we thought that we needed. But after a year, maybe we needed 25% more. And then coming back and renegotiate the contract for those extra licenses is not a great negotiation position. It's better to have all the sort of levels in the initial contract. So in case you need to scale up, you sort of have the contract and terms in place. So that's highly recommended to do. We also try to be very open and communicate a lot about the programs. But as you saw, it was a lot of things going on, not only our things, but the other security initiatives. And I can understand it probably became too much for some, especially sort of higher ups, which would get everything. So I think we could have sort of over-communicated in more communication channels than we did. And ideally, we would have all the policies, all the capabilities, everything in place, and then do the training of everything. Because when we did the training, like the people that got the training in January last year, not every capability was in place, so they didn't get the full training. So we sort of need to backfill and things like that. Not ideal. The plans forward for us is to optimize and tune and tweak every solution that we have rolled out. We have done it quite fast, so we sort of need to step back and actually try to get the most out of everything, and also try to integrate everything into a single pane of glass, so it's sort of easy for teams to get a good overview. We also have a vision, I would say, around this application inventory, to develop it to be what we call an automated risk scoring system, to sort of give each team sort of a automated risk on which applications are the highest risk. And we want to take a lot of different factors into account to sort of come up with that risk calculation. It could be like a server has been running for 1 year. That's not good. Or ideally, in a perfect world, I would like to see sort of this team, everyone has taken the security training, so it's sort of good for the risk score. That's, let's see how far we get. I would also like to deploy cloud-wise deny actions, like some things are just too high risk, so we should never allow it. And we want to launch something like a security champions program. Not sure exactly how that will be, but this is sort of very high level things we think about going forward. So that was it for me. Any questions? Yes.
So I'm going to do this in Norwegian. Sorry for only speed.
I can repeat it.
Så jeg har litt skryt og 2 kommentarer. Skrytet er litt, det er jo dritbra. Veldig imponert hva dere har fått til. Det er pragmatisk, og det er min magefølelse sier at det her er riktig gjort. Men uansett, kommentarene, punkt 1, det er strategiske avgjørelsen med å få inn en sikkerhetsansvarlig som både har mandat og penger til å gjennomføre det her. Helt fantastisk. Det er big deal å få tak i de riktige menneskene og få det gjennomført. Det er liksom startpunktet for alle. Men jeg hang den første tingen du kom med, det der med at usability over security. Tommel opp, tommel opp, tommel opp. For det er liksom det store problemet når det gjelder sikkerhet. Fordi at utviklere i basis skal lage funksjonalitet, ikke sikkerhet. Og det å ha det som en sånn noe å stå på når du bygger videre rundt sikkerhet, gull. Så veldig imponert.
Takk. I'm not sure how to summarize that, but have security high on the company agenda and be pragmatic, and usability actually is more important than security. I have a new member in my clan. That's good. Yeah.
When you started like scanning your applications and your domain, did you have to like contact your external service providers, like you ran your websites via services, or did you contact them and say that you were going to scan and stuff beforehand, or did you just scan and say you might see some traffic?
So the question is, when we collected all the domains and started scanning the domains, if we excluded third parties or let them know or asked for permission to scan them. And the answer is we really didn't do it, like we just scanned. But our scans are they are not intrusive, they don't take down things. So it shouldn't be a problem. If it's a problem, then that's a pretty weak system. So that in itself is a vulnerability. But in the bug bounty program, we exclude all third-party services that we don't have permission from. And we have also opted the standard contract in Schibsted for all vendors to have this clause that we are allowed to test their solution. So we can actually include them in our bug bounty programs. So that's a good question. So we are improving in that area, but a bit wild in the beginning, I would say. But it never caused any problems for us. Yeah.
When you talk about training developers, do you also have the opportunity to get, say, QA or product managers or architects or other sort of surrounding roles involved in the training as well?
Yes. So it may seem like it's only developers in this talk, but it's really the product teams. Yeah, so it's the whole product team that was or got invited and could attend. So yeah, definitely. Like the product manager is very important, I would say, or product owner or whatever you call it. It's important to have the security culture, not only for developers, but everyone needs to have security in back of their mind, basically. Yeah.
On the bug bounty, you have run 4 and the 5th launch now, bug bounty programs. How do you manage to onboard the companies? You have many products and platforms. Do you have any kind of way of operating there, or you try to find the champions in the company and try to encourage them?
So PIN themselves sort of took initiative, launched it themselves. We in the central team, like I was the owner of getting a contract with the bug bounty platform and not really getting teams to start a program. So the security team have launched one centrally, and that covers all the domains that can affect the end user login sessions across Schibsted. We have Schibsted account as a central SSO solution. So in the central program, we have all the domains that sort of are subdomains of those SSO solution, could have impact on that. We did sort of announce internally that everyone that has more than X dollars in revenue, we believe should have a bug bounty program, but there was no enforcement, and they just sort of came to us and wanted to do it. Bug bounty programs are sort of, it sounds very sexy and cool, so I think in general people like to do it. So we really haven't had a big push, and it sort of, yeah, organically grows, and it helps with sort of sharing experience around it internally as well, I think. And maybe the security culture part has changed this as well. Who knows? Yeah, there was a question. No? Okay. Yeah.
In your risk scoring system that you have, you mentioned that you sort of tell the product team then, hey, this should be your next risk reducing activity to undertake to reduce your risk. So what did you use to sort of define the priority of what your next task should be? Is it only based on what is the highest risk that you have currently and try to mitigate that? Or did you, for example, also take the ease of mitigating into account when defining the next thing to do? Can you tell me about that?
So the question is about how to decide what risk to tackle first for the team within the team.
Yeah.
And we in the security team didn't really get into that. It's all the teams themselves that make that decision. So part of the threat modeling session, they sort of vote on the highest risks. So the team collectively decides themselves what's the highest risk.
Okay, thank you.
And back.
When do you decide the product is ready to be externally tested using a bug bounty program? Because there will always be something in back. When you
Yeah.
now we
So the question is, how do you decide when a product is ready to be part of a bug bounty program? And what we have done is actually say every domain that has dev in it, they pay less for findings, but it's still part of the program. And we have a few domains around payment actually that are excluded just to reduce the noise because they are intentional insecure. So you can sort of manipulate the prices and stuff in the front end in development environment. So I've sort of taken that out of the scope because everyone will see, oh, this is a critical while it's intentional. So I think the general thing that we approach it is like everything that's exposed to the internet are in scope and should be in scope because your dev environment shouldn't have production access, but you never know how it's actually set up in practice. So it can have quite big impact even though it's a dev environment. So I said everything on the internet is in scope. Anyone? Yeah. Yeah. Shoot.
Yeah. So you did its talk on application security on lanes in your first
Yep.
slide. I think do another talk and have that kind of depends on the other lanes. Which is, that's really interesting.
Yeah. So the comment was, you only talked about the application stream in the cybersecurity program. It would be interesting to learn about the rest. So I definitely agree. I think we should be open and share. Not everything has gone as planned everywhere, of course. So it's a lot of learnings. I think in general, we should share more, be more transparent and open around security. It's not like a competitive advantage. It's something that we should and must collaborate more on. All right, then we are 45 seconds over time. So thank you.